What's going on, y'all? Sean of Math Swap Tutoring here with another calculus video for you. This video, I am going to be talking about critical numbers. But before I get into it, make sure you like the video, make sure you subscribe to this channel, and um, and make sure you pay attention. Critical numbers are a very key concept in calculus and pretty easy concept as well. But let's go ahead and explain it. All right, so what is a critical number? So I have it plural here. I'm going to say critical number. A critical number is a number denoted by C in the domain of a function. If you remember what a domain is just like the set of X values that are in a function. Um, a function F where either F prime of C uh, doesn't look too neat. So where either F prime of C is equal to 0 or F prime of C does not exist. Okay, so let's read through that. A critical number is a number C that's in the domain of a function F where either the derivative is equal to 0 or the derivative does not exist. Okay, so that means if you remember, if you watched my last video on Fermat's theorem, you know that Fermat's theorem basically said that if you have a max or a min somewhere and the derivative exists, then you know that um the derivative is equal to 0. However, we also know that not every place where you have the derivative equal to 0 is a place where where you have a maximum or a minimum. So that's a whole separate kind of conversation. Here we're saying a critical number can either be where the derivative is equal to 0 or where the derivative does not exist. So either place, the derivative can be 0 or it can just straight up not exist. All right. So let's go ahead and just do a couple of examples here. So find the critical numbers of the following function. So say, for example, we have the following function. F of x is equal to x to the 3/5 power times 4 minus x. Okay. So try to solve this on your own. I always recommend that. All right. So now we're going to find the first derivative. So what is f prime of x? It's going to be equal to, so you have something times something. So this is going to use um the product rule. It's going to use a couple of things. So when you use the product rule, it's going to be the first times the derivative of the second. Now, there is no exponent on the outside of this parentheses, so we don't have to do like chain rule, but we're going to take the derivative of each thing on the inside. Derivative of 4 is 0. Derivative of negative x is -1. Plus the second times the derivative of the first. So the derivative of x to the 3/5 is going to be, let me do that, 3/5 times x to the, now, this -1, that's going to be to the -2/5. Okay. All right. So let's go ahead and kind of clean this up a little bit. So f prime of x is equal to -x to the 3/5 power, um, plus, so I'm going to go ahead and let me see what I want to do here. I'm going to go ahead and distribute the 3/5 first. So it's going to be 12 over 5 minus 3x over 5. Um, Actually, let me do it this way. Let me actually kind of multiply everything. So that's going to be 12x. I mean 12, yeah, 12x to the minus 2 fifths power over 5 minus 3. Now, so you have an x and then an x to the 2 fifths. So that's going to be 3x to the 3 fifths power over 5. Okay. Now, so if you notice, we do have like terms here. This one, let me just kind of go ahead and denote them. This is a like term with this because they both are to the 3 fifths power. All right, so let's keep on going. So negative x to the 3 fifths and then negative 3x over 5. I mean, yeah, negative x to the 3 fifths minus 3x to the 3 fifths over 5. So if we treat this like 5 fifths, so that's going to be negative 8 fifths x to the 3 fifths power plus 12x to the negative 2 fifths over 5. Okay. All right. And so that is, so we'll kind of try to clean it up a little bit here. All right. So let's keep on going. Let me take my work over here. So I'm going to factor out I'm going to factor out a 4 fifths. So you have 4 fifths times, that's going to be, oh, yeah, I do it that way. 4 fifths, uh, that's going to be 2 - 2x to the 3 fifths power minus, whenever you factor out a 4 fifths from here, you get a 3. Um, and then I'm going to do this here over x to the 2 fifths. Okay. Is that all that we want to do? Okay, so we can actually kind of clean this up even a little bit more. So what can we do to factor out some sort of um let's see. What can we do to kind of factor out, make this a little bit cleaner? So if we were to factor out um let's see. If I wanted to get rid of this down here, I could multiply the whole thing. Let me see. Let me think about this. Um I could multiply, if I multiplied the whole thing by x to the 2 fifths. Okay, yeah, so let's do that. So if I multiply this whole thing times x to the two, actually, that's not how I want to do it. Um, sorry, let me think about this because I have it here, but I'm trying to like do it here in real time so I can explain it a little better. Okay, let me do it this way because I think the way I'm doing it is a little bit more confusing than it needs to be. Let's do it like this. So instead of factoring out the 4 fifths or whatever, this is what I'm going to do. So you have 12x to the minus 2 fifths minus 8x to the 3 fifths, all of that over 5. Okay. Now, if I were to factor out a negative 2 fifths from both of these, what happens is, remember, since it's exponents, you would essentially subtract it from the exponents. So so factor that out, that goes to 1. So this would be x to the negative 2 fifths. Then you have 12 minus. So when you do factor out of x to the negative 2 fifths from here, essentially that just means that you subtract it. So that's going to be 12 minus 8x over 5. So then finally this becomes 12 minus 8x over 5x to the positive 2/5 power. Okay. Now, that is the derivative of this function up here. Now, let's find the critical numbers, okay? So yeah, sorry, that was a lot there. I was trying to do this in a way that wasn't confusing and without having to follow my notes too much on here on the video. All right. So to find the critical number, remember a critical number is where the derivative at point C is equal to zero. Okay. So what we want to do is we want to set the derivative equal to zero, and that's going to help us to find where the critical numbers are. So therefore, um, so 0 is going to be equal to 12 minus 8x over 5x to the 2/5 power. Okay. So then if you cross multiply, that becomes 0 equals 12 minus 8x. Add 8x to both sides. So 8x equals 12. And therefore, x is equal to 12 over 8. You can take a 4 out of both of those. That's going to be 3 halves. So that means that there is a critical number at x is equal to 3 halves, um, because that's where the derivative is equal to zero. Now, the other thing to keep in mind is look at the denominator of the derivative. Because there's a somewhere you can plug an x in there in the denominator, what if x is equal to zero? If x is equal to zero, then the derivative doesn't exist. So that also means that x equals zero is a critical number. X equals zero is a critical number because that is a place where the derivative does not exist. Both of these, here's a place where the derivative exists and is equal to zero. And here also is a place where the derivative does not exist. So that means anytime you find the derivative, you need to be looking in the denominator to see if there is a if the derivative can ever go to zero. Hopefully that makes sense. All right, so let's do another example here. All right. So the next example I would like to do is here's your function. F of x is equal to 5x squared plus 4x. So find the first derivative, set the derivative equal to zero to find any critical numbers that way, and then also see if there's any places where the derivative doesn't exist. Okay, so those are the 3 steps. Okay, let me even write that down. So find the first derivative, set it equal to zero. That's to find any critical numbers that way, and then determine any places where the derivative does not exist. And in particular, you need to be looking for a denominator that can go to zero. Can go to zero. Sorry, let me rewrite denominator because that is like totally unacceptable. This thing doesn't, it's not really accurate to my writing. Okay, all right. So first thing, we're going to find the first derivative. All right. So 5x squared, we're going to use the chain rule. So the derivative of 5x squared is going to be 10x, and then the derivative of 4x is 4. All right. Now, second step, let's set this equal to zero. So 10x plus 4 equals 0. We're going to subtract 4 from both sides. Okay, so 10x equals -4. Divide both sides by 10. So x is going to be equal to -2 over 5. So x equals -2/5 is a place where we have a critical number because that's where the derivative is equal to 0. Okay. And then also, do we have any place where the derivative does not exist? No, we don't, because if you look here, this is continuous for all of every value you plug in for x there is going to be continuous. Okay. So, um, yeah, we'll just leave it at that. That's how you find critical numbers. Basically, I could do some more examples, but I just want to give you like a little taste. Anyhow, hopefully this is helpful for you. Make sure you like the video, make sure you subscribe, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.